next level.
Hey everybody, sorry for such the short notice, but they've started this Breakpoint 2 game testing session early. So here we are. I didn't want to miss anything, and let's go ahead and chime in.
My name is Ryan Barley. I'm also somewhat new to the video game space. I actually originally started as a film editor and director, and worked a lot in post-production and production. And then I, saw the potential of video editing in real-time kind of applications, and basically just changed to becoming an engineer. After I worked for a while, I came on Stadia as originally kind of a dev evangelist for Stadia and for graphics. And now I am a product manager at Google Stadia, specifically focused on developer experience and testing. And then as far as my favorite games, I'm going to throw an audible. I've been liking board games a lot lately, and specifically asymmetric board games like Root. But if I had to say a video game, again, somewhat embarrassingly, I've just finished Last of Us 2. So that's definitely my favorite right now.
Awesome. Stefan.
Yes, hello. I'm Stefan Posthuma. I'm the head of technology for Electronic Arts' internal quality verification organization. So we test all of EA's games. Everything that we publish gets tested, of course. So that's everything from AAA Gen 5 consoles to mobile, handheld, Switch, and so on and so forth. It's a big, 1,000-person organization that does that across EA. And my focus is purely on the technology behind, our testing, mostly to do with automation, AI to drive testing, and other technologies that we can employ to make sure we actually are still able to test these games that keep getting bigger and bigger. I've been in the industry for, I don't know how long. Like I started making games in the 80s, so do the math. It makes me feel way too old. Favorite genre, RPGs always. I've been, ever since Baldur's Gate, I've been playing RPGs on PCs, and Elder Scrolls, The Witcher, those are still my absolute favorites.
Awesome. Thanks everyone for that. So I'm Abel, Mathew. Previously was co-founder and CEO of Backtrace, which is a crash and error reporting solution predominantly used in games. And currently the CTO of Sauce Labs, where we focus on all things testing across a variety of verticals. Favorite genre for me, and this is going to be, I'll be the odd man out, Metroidvanias. I definitely love a good Metroidvania. I definitely get addicted to those as well. Though I will say, Stefan, just as a fan, like Command and Conquer was what I grew up on, just from the EA family. So I'll throw that one out there too. RTS.
Same here. Red Alert 2 is one of my favorite games.
Yeah.
I played those as well back in the day.
So first of all, thanks to the panelists for joining us. And for those of you viewing, we've got, as you can tell from everyone's different backgrounds, we've got a really good group of people to talk about game testing. Game testing is actually a fairly complex, multifaceted discussion. So what I thought we could do is start off by talking about how various game development teams approach testing and the testing strategy. What's really interesting is that might lead us to this idea of what I call testability, but how your game development changes when you think of testing from the get-go. When you think about testing during the software development stage and actually the full game development stage, and it introduces the question of what sort of data and instrumentation should you be thinking about so that you can improve not only the testing, but also post-release as well. And then finally, because we're all technologists on the panel, I'd like to open up the floor to talk about where you see the future of game testing going. But let's start about this idea of testing strategy and how you approach it. So Ari, as you mentioned, you worked on titles like Returnal. I was wondering, could you walk us through how did the team at House Marquee really approach testing Returnal? Everything from what was the strategy to testing, how did you, like, what was coverage, and how did you even have that conversation about quote unquote coverage? And then the resourcing involved there. Who was actually doing the testing? Was it a single team's responsibility? Was it distributed, and the like?
Yeah. So when we were at Housemarque making Returnal, we were growing the studio a lot. We started from a small arcade game making studio and then ended up at this, Returnal sized studio. And we had to scale up our processes to follow accordingly. And we started with, we had a team of QA testers. There were like 2 or 3, not that many of them. And then suddenly now we had a bigger game with more content than what our previous titles had used. So we had to scale up our process also. And it was quite hard to scale up the company, but luckily on Returnal we had help from Sony. So they had a dedicated QA team that really knew what they were doing. So what we decided was that we would complement their kind of more traditional AA, AAA type of testing with our, maybe if you would say non-traditional, where we would have our own internal QA basically seat with the feature teams and participate in their dailies. So they would kind of know what's going on, what new features are coming out, so that even if we're not explicitly asking them, hey, test this feature, they would still be aware of everything that's coming out. And then we had some automated testing, but we didn't have any framework to work on, so we kind of were starting from scratch. And it almost took as long as making the game itself. We did make it before production ended, and it was very helpful. With help from Sony, we had one engineer there. David, you're awesome, you rock, you're a hero. And that helped us basically autoplay through the game to find very memory crashes and figure out the frame rates.
Yeah, could you also talk about the scale? Obviously having Sony, just in terms of how many people were actually involved when you talked about testing.
Oh, wow. Okay, so like I said, our internal testing team kept being a small size, a few people, less than a handful. Actually, the Sony team, that kind of grew and expanded and retracted ad hoc depending on how much we needed. Sometimes we would have 5 testers, and sometimes it would scale up to 10, 15, or maybe even more. And then, of course, we outsourced some of the testing to our friends and family, where we would have a friends and family playtest. We'd have a build. They were okay, this is kind of good. Let's now get some feedback and, free testing. So we would invite our friends and family to come over, get your name in the credits, play the game, have someone look over your shoulder while not saying anything. And then we would ask them to fill out a detailed Google Doc about how they felt about all the features. And so we would get some, user feedback also.
Yeah, that's super interesting. And I'm still wishing you sent me the invite during that phase. But Shane, I'm curious how that matches with what you experience, as someone, as GameDriver, and working with several studios. What might you add to what Ari said to really complete the picture of how some game development processes approach testing?
Yeah, it's interesting and listening to the sort of evolution of Housemarque, because I remember some of the earlier games, the top-down kind of bullet hells of the earlier company. And so we've worked with companies that are in different stages of their growth and maturity. From the dev is the tester, the 1 or 2 or 3 people that are doing the development, they are the testers, to medium-sized studios where they actually bring someone on to do the fun job of testing the same game every day for months or even years at a time. And then the more mature studios that try to build testing into more of a continuous delivery pipeline. And so it's always interesting to kind of see where a company's at and what stage of their development, their maturity, their both the company's growth, if there are a repeat studio, or in just the game itself, and how the development process evolves along with it. Like you said, the test automation came near the end of the game's life cycle in terms of the initial release, but that's not uncommon for a game that's going to have a lifespan for several years.
Yeah, in this discussion, I know we're focusing on games that are released and obviously have a kind of a discrete timeline. But I'm sure it looks differently when you have a long-standing title and something that's maybe released on a frequent basis. So I wanted to turn over to you, Stefan, because you see this at EA. How do things look differently for these types of titles versus kind of your classic release in discrete timeline type game?
Yes, highly disciplined. So the sports franchises, I think those are the ones we were talking about, right? FIFA and Madden have their yearly release cycles. In general at EA, the QA and QV teams are deeply integrated with the development team. So they work side by side. They're there throughout the entire cycle of development and release, especially for those sports franchises. I mean, it's not like they ever leave, right? So they're part of the dev team. Even though, we have a central organization, they're embedded, they're co-located, as far as that's possible today with COVID. But, and there are fairly strict processes in place to, we have this so-called gate process where there's gates during development where we have very specific, reviews of things that need to be complete. And that includes, their ability to test whatever it is that they're either adding or that's already existing, or so. And then there's a lot of business process around that to make sure that those things are adhered to, because they cannot afford to have a huge backlog of Class A bugs on FIFA, because that game needs to ship every cycle, right? So it's really about, like I say, discipline and a very, very mature model, because those games have been going for decades, right? So that model has matured, and especially in the last 10 years, I would say, very significantly. So that's really, it's like, discipline, process, and, fairly large budgets as well, I might add.
So I'm going to put something in the parking lot, so to speak. This idea of, we're going to touch back on it, the idea of that, the co-location or the QA teams being embedded, sitting alongside the development process, because I think that might inform some of our discussions about how do you approach game development with the idea of testing in mind, or testability. But before that, I wanted to kind of touch on this idea of the complexity of game testing, specifically around multi-platform games. It's the world we live in now. And so, Stefan, going back to you, so for EA's testing strategies, pushing to like multiple platforms, what does your platform pipeline look like, and how do you even approach this?
Yeah, that's an interesting topic, especially in the last couple of years. It's not unusual to have a game that is targeting 6, 7, 8, 9 platforms, right? Like Gen 4 console, Gen 5 console, iOS, Android, Stadia, Switch. If you add it all up, there's a lot of platforms there. So we have. So, the classic model of doing a build per platform and sending it off to, a testing group who's then going to, test all those 9 builds. Let's say you have 9 platforms. Every single cycle is not practical. It doesn't scale. So you have to get very specific about what your development plan looks like, how QA is integrated into that, and then you go deep on technology, right? So you look at is there anything that we can do that's platform independent? Right? Are we able to separate our simulation that is mostly platform independent and test that, discreetly? Do we have CAD labs and type of situations where you then take your actual platform dependent testing and do that in that fashion and build large infrastructure to support all of that, right? So, you need to have a company that has the ability to do so, right? The operating budget of the QV group at EA is large enough to ship multiple AAA games, right? So that's really what it requires in order to be able to do that, at least at the scale that we do it at EA. I think if you are a smaller company and you aim at multiple platforms, then you have to get extremely creative about how you approach that, because every platform has its own idiosyncrasies. Rendering systems are usually different. So you have to come up with ways of kind of separating things from the platform, visual verification of assets, right? So if you have an image or a video that comes out of something, a runtime, whether that's a mobile phone runtime or a a Gen 5 console runtime, you have an AI that can look for rendering anomalies. It doesn't really matter where it comes from, right? So at that point, you're completely platform agnostic, which is really important, again, to start thinking in those terms, right? And the old school way of, like I said earlier, one build per platform and chuck it over the fence to QA, not going to work.
Yeah, super fascinating stuff. We'll come back to some of the items that you mentioned as well. But I wanted to open up to Shane. And so the complexity of multi-platform testing also kind of creates a catalyst for testing automation as well. And so, GameDriver, how are you thinking about how does the fact that we live in multiple target platform world for games, how has that influenced GameDriver?
Yeah, this is a big part of our strategy was, looking at the last 20 plus years of test automation in enterprise software, which, went through multiple kind of stages where they had to address things like browser compatibility before the engines were quite standard there. And then into the mobile era where, what do they call it, fracturing or just the sheer number of devices and platforms that you needed to support was just too many. And so, in gaming, it's, as Stefan had said, it's that times 10, right? So really our objective has been to try and enable a level of automation that would allow you to write tests, agnostic of the platform that could then be executed on any of those supported platforms. And that's not always, a one-to-one because of like you said, things like platform-specific features, Switch versus, PlayStation, they have different input devices, that sort of thing. So there's some subtleties there. But for the most part, our objective is to make it as seamless as possible. One set of tests, one repository, execute wherever you can, and then just have some logic that would kind of deal with the platform idiosyncrasies. Meanwhile, you're collecting data from, profiling tools, which we work with a few. And then you can see across the board, like how are things performing on, last gen consoles versus the current. And again, for mobile devices, that problem still exists. We have customers that are working across everything from like old 32-bit Android devices to current day, very, very fast modern architectures. And they want to ensure a quality experience across the board. So that's a different focus than the different platforms, but it is still very much relevant.
Yeah, totally. I mean, we see that at Backtrace as well, where like it's the illusion of mobile just being two things, right. iOS or Android. It's actually not the case. People who are developing games will want to develop it for much older generation phones that might have, as you said, be 32-bit. We've seen 16-bit in one case as well at Backtrace, where we'd have to go and support our SDK for those things. Yeah. But obviously, the name of the game is you want as many users as possible, right? So the wider the support, the better. Which kind of takes me to this idea. And by the way, we'll also touch on the fact of like this platform independence, and we're going to put that to the parking lot as well, because it's a really powerful idea when thinking about game testing. But it brings us, all of that discussion brings us this idea of like testing being super important, the complexity of games, whether it be multi-platform or the game itself and dynamics, etc. Ryan, you said something to me once, something along the lines of like the most important user journey to improve game development velocity is the tester's journey. And this idea that like thinking about how the tester's user journey, right, how they're testing it, etc., can greatly impact your ability to develop a game. And so I wanted to tell, first of all, like where that statement came from and kind of the thoughts behind it. And then also how it influences what you're doing when you think about testing at Stadia.
Yeah, so I definitely, you reminded me of saying that, so I appreciate that, Abel. And I recall it was in a point in time when it was very important to us. The tester really did determine whether or not a lot of the content of Stadia could actually, exist. And I think, if I back up a little bit and talk about kind of the history, like I said, I joined Stadia as a dev evangelist for graphics, and right away realized that as I was making, very early on, as I was making the Hello Triangle kind of just general, how do you get up and running on Stadia? I remember thinking to myself, like, it is extremely hard to develop on this platform because, the tools were early. They were extremely focused on a very specific user, someone who's already, deep into cloud and that type of thing. And so I wanted to I kind of shifted my focus a lot into the developer experience to make that an easier experience across the board. And when we did our first public beta test of Stadia with Ubisoft, when we did Project Stream, we had actually originally built a foundational set of tools that we've continued to build upon since then. But even at that point, the tooling was very low level. It was very Linuxy. It was CLI based for the most part, and so it required a level of expertise that, again, we weren't really leaning into the testers being at that level of expertise. And so then, fast forward a little bit more, when we get to the launch of Stadia, I was actually flying around the world and embedding in a lot of different teams to ensure that we were able to launch a bunch of these games that we were very excited to launch. And one of the things that was great about that for me, again, at that time, was that I was able to kind of see the way in which our partners were using the tools in, somewhat of a duress, not a duress, but, a tense situation of game launch and platform launch and all of these types of different things that are going in there. And one of the things that I came away from it was, every single role wanted to test. Like, no matter what they were actually trying to accomplish, the kind of central user journey was, I want to be able to, test this game to see something going on with it. And that really hit me at that point as being this kind of very important user journey that we had to target even more. It wasn't just the low level developer who can get things to work even if it's lifting mountains. We were looking at QA, we were looking at producers, we were looking at release managers, we were looking at executives, even our own internal, our own tech cert, our own PMs, our own engineers. Like, everybody wanted to test the content. So it really, it had a large kind of profound effect on it. And so after we had launched, I transitioned over to being a PM, specifically around developer experience and testing. And we made it a priority internally after that point to lean into our infrastructure. Like, one of the things that's really great about Google is that we do have infrastructure at our fingertips that can really help in solving a lot of the problems that testers have at scale. By automating, just gathering of the elements so that you don't have to use SSH or SCP to download some Linux log that then needs to put through another CLI and that type of thing. And one of our original expectations of that was that if we could increase the efficiency of the tester, right? And that could be, like I said, all of those roles. If we could just increase the testing user journey, then we really believe that we could increase the efficiency of the entire team. Similar to we thought about it as the rising tide lifts all boats. If we could really nail into that tester, that was the common denominator. They were non-technical. They needed a lot of information. And everyone did. So we would just make all roles much better than that. And since then, our bet really has paid off that the tester was the user journey to kind of really focus in on. because we've significantly reduced from launch the amount of times that it takes partners to certify, and we've really changed the way our partners think about the Stadia infrastructure at large.
Yeah, so it's really interesting, and it's cool to see the journey that Stadia went on through that. And so one of the things that we talked about previously that I want to bring up again is this idea of embedding QA, or like having teams work alongside the game development teams as well. And so to Ari, specifically with Returnal or any of the games that you worked on, how did that actually influence the way the software was written, as well as the game development process?
Having the QA embedded in the teams, how did it change how it was written? I'm not sure if, I don't think I maybe perceived it myself if there was a change in how we wrote the code, like just having the QA be a part of the team. But it did change drastically how informed the QA team was of like everything that was going in the game, because we weren't just testing in the end. We were testing constantly during the whole like process of making the game. And it's very hard when a QA is so disconnected from the team and we make a new build and then they're testing and they're like, this is new. Is this supposed to be there or not? So I think it's quite vital to somehow make sure that QA can be on the same page as you. Know what are the features that are in, what features are in progress, what stage are they at? And the easiest way is just to include QA in your daily. I think every team should include someone from the QA team into their daily, every feature team. And just by doing that, I think we managed to improve the quality of life of QA for sure. And of course, if you have a well-oiled QA machine, you will have a better game for it.
Yeah. Also, specifically thinking about this idea of like introspection, right? When you're developing the game, and specifically like how it changes what's written is something we'll talk about in a bit is this idea of like instrumentation. And so like, how do you bubble up the right data for your teams that are testing, or even the folks that, your friends and family, right? When they experience a bug, and like, how do you get them to be able to capture the right data so that they can log it in the document where you're asking them to archive this? And so that actually, Stefan, I wanted to open up to you as well, because this is what some of your team members do with these games, is to work alongside. And so I was curious at the scale that you work at, what's the typical stage that these teams really begin to work at during the game development process? I'm assuming it's past ideation and like when development starts, but like I'm actually quite curious about what the typical pattern is of engagement.
Yeah, so I mean, there's two there's the fully embedded QV team, so we call it QV, right? It's a combination of quality engineering and quality assurance. It's very important to make sure that we understand that there's engineering involved there, right? And that can work with the development team. So those teams are by default embedded with the dev team, so they are part of the entire process and end to end, right? And areas, as you said, that's crucial for them to be fully included in the development process, so they have full access and full visibility to what goes on in the team, but also they are there from day one when it comes to technical designs and implementation of complex test automation. So they are there from day one. There's also when we started talking about this head of technology role for our quality organization, this is about 5 years ago now, I think. It was really about, we need to have, in addition to that, we also need to have some kind of like a high-tech strike team or whatever you want to call it. Is that I need to hire some very senior and very, highly qualified game development engineers that can help me build some of these forward-looking technologies like, advanced test automation, using AI to actually test games, right? So, and that's a separate team that sits in my organization where we go and look around the development organization, say what teams, what projects are being spun up, what are teams doing, and where do we think we can use innovation and automation and other advanced technologies to help them actually test these games far more efficiently than they would if they would do that the old school way. Like we're looking at a new project, for example, that does a lot of almost the entire game is based on user generated content. right? So, and if you start thinking about what that means technically, and it's a highly complex technical challenge for them to even build that game, let alone to test it, right? Because there's a combinatorial kind of, space of possibilities there of when users start modifying things and so it's not something that is statically tested, right? It's impossible. You can't do it because you don't know what people are going to come up with, and knowing our players, they're going to come up with some pretty creative things in that game. So we are working with this team from the very beginning and talking at the deep technical level about how are you going to do your dynamic retargeting of animations so they can interact with any object, or how are you going to do your the development of all these kind of user-generated content systems, and how are they going to interact? Because we need to know how are we going to test that, and how we're going to automate that, simply because manually testing that is not, you can test the qualitative aspect of that game, and you can say, is this fun? Is it a good player experience? But the mechanical aspect of testing, we need to heavily index on automation because otherwise we simply cannot guarantee that game is mechanically correct. So that's where we, go in with, I have people who've been in the games industry for, 15 years or longer, very principal software engineers who are in my team, who are part of the QA organization, right? I'm always people get really surprised saying, well, you have principal level engineers. Yes, we do, simply because we need to be able to understand what these game teams are doing, right? If there's a big new open world game or a game so we really look at specific use cases of what technologies are they aiming at, and how do we work with them from a technical perspective to make sure that we are able to test that.
Yeah, that's fascinating, because actually it brings us to the next topic, and I want to go back to you, Ari. So we've got the co-location, or the embedding of the QA, QV, and the like. One thing I was really curious about is different game testing modes, and so I've seen this quite a bit, and this idea of you have a different mode within the game just specifically for testers or for automated run-throughs and the like. What did that look like for some of the games that you were part of?
Yeah, well, be sure not to ship that with your game. Speaking from some personal experience here. So when I was working on the mobile games like at Rovio and stuff, those are mostly server authoritative games. So to make it so that people could test it without exposing any security flaws, we would have a dedicated website that only authenticated users could go to. And there they could give themselves, all these kind of bonuses and stuff that would allow them to simulate a fast progression. Going from that to Unreal Engine game, for example, in Returnal. Actually, at Epic Games, when you use Unreal Engine, we have built in something called the cheat manager, which allows you to easily implement your own cheat code so that you can invoke anything using a console command. And then that will get compiled out in shipping. So if you do it properly and adhering to the standards, you won't have a problem. But of course, console commands aren't that usable by many. You have to know of them all. You have to have a Confluence page somewhere listing them all. So it's much better to just be able to click a button on your keyboard and have a debug menu come up with all the buttons and all the drop downs. And that's what we did on Returnal, for example. And I think that was actually very useful for us. So these tools were insanely powerful because it's not only for the QA testers, and quality engineering. It was also for the developers themselves. It was for feature teams. It was for the designers, and so on and so forth. And for anyone willing to or wanting to run into a specific part of the game. So we had a button for going into each and every biome of the game. We had a button that would list all the levels in that biome, all the rooms, and then you could teleport into each and every one of those rooms. You could spawn any weapon in the game. And we even had a button where if you went into a specific biome, because at some point in the game, you needed to be at a certain proficiency. We assumed you have this many items. You've been playing the game for a while, your health is bigger. So how do you emulate that? So we had one button that just kind of auto-equipped the player with a reasonable build for what they should be at that point in time of the game. And I think that was crucial to development. It really helped us to do fast iteration, especially because at some parts of development, we were having issues with memory, and it wasn't possible to play through the entire game. We weren't cleaning it up correctly. So being able to do, like after a crisis, just jump straight in, say I was in this biome at that room, and just dive right back into it was, crucial.
Yeah. That actually introduces, so when I'm thinking about beyond, like specifically with development of the game and thinking about testing, Stefan, during one of our conversations, you and even earlier in this one, you brought up this idea of platform independence being a top of mind thing when you're thinking about testing. So in the vein of like, how does testing change the way the game is developed? You had one story here about that really kind of represented this idea of separating simulation versus the presentation and really thinking about that in terms of platform independence. And additionally, how not thinking about these things at various stages of the game could introduce problems down the road. And so I was wondering if you could share some of those stories.
Yeah, that's a good one. So the team that I have, one of the things that we do is look for ways to, like I said, automation, right? Automations are one major pillar. And one of the things that we do is looking at training ML agents to be able to play games to a certain extent. And we're working with the golf team that's in the Tiburon studio. And we're looking at, if you think about what a golf game is, it's really a series of golf swings, and the golf swing is fully parameterized, right? That's a perfect case for automation, because it's really a set of, this club with this, swing, I don't know anything about golf, this swing angle and power and this and that, right? And then the simulation takes over, physics kick in, the ball gets hit and starts flying. But all that stuff is, where it's going to end up, that you don't need to simulate the flying. So what was happening is that we were able to fully, we were able to train an ML to do the golf swings, right, and pick the right club and so on. It was really, really very successful. The problem was that the game, we came in quite late into that game development. So the game itself had a lot of presentation around. When you think about a golf game, you see the golfer walk up to the tee and they kind of stand there and they, get themselves ready. That's all, and it's a nice presentation. That's what players really like about that. And then the swing happens, and then there's a beautiful camera, following the ball and so on, right? And there's audience clapping and so on. Now, which is all good, right? It's part of the game. However, for automation purposes, all of that is not necessary, and nor do we want it, because that added, of course, a lot of time in between swings. So and so going back to the dev team, say, hey, can we turn all that off, and can we just go from swing to swing and fully simulate that? It's like, no, right? The game wasn't architected that way, right? Some of these things are deeply embedded into our systems, and trying to turn those off is going to break, a lot of other things, and so we'd rather not do that because that's too risky and so on. So ultimately we ended up just training our MLs while these camera things were happening, and managed to speed a few things up here and there, but ultimately it was a very inefficient way of doing it, because it could have gone a lot faster. So that's a very good example of how you would need to be part of that dev team and part of the, if you're going to architect this game, well, we know we want to be able to automate it. Therefore, certain architectural decisions have to be made where you can more easily turn pieces of presentation off, or completely separate presentation from simulation, or have replay buffers, or whatever it is you need to to enable that automation. Is not something you want to retroactively try and build into that game, because dev teams are obviously very sensitive to risky changes. So that's a very good example of how. That's why it's so essential you get in there early, and you have engineers talking to engineers about what does it mean if we want to automate this, and what type of changes do we need to make, and we work directly with the dev teams. And if they say, well, we need extra hands to be able to do that, well, then we provide those hands and they work together.
Yeah. That brings me to the one question I have for you, Shane, which is, as you at GameDriver Engage, we talked about game testing automation and the like. Curious to hear about how you see GameDriver impacting when adopted earlier in the development lifecycle.
I think it's not so much the tools that are being used, such as ours, but the synergy between the testers and the developers that we've talked about already, where we've seen great success. So where the teams are separate and not using the same set of tools or not looking at the same code in solving their problems, we find that they tend to struggle. And so we really do recommend that automation starts earlier with the developers, with the testers. If they're not embedded in the team, at least they're working in the same sort of common tool set, and they come up with the requirements together for what that looks like, what they need from test automation very early in development, if possible. And that's where we see things really kind of hum, right, from an automation perspective. Like, what we try to do is provide tools that are of value to the developers early on, as you might consider as a unit test or set of unit tests that can then be passed to the dedicated tester or testers in that team to extend upon and to build more complex scenarios. And we see that working really well. Something Ari mentioned about the sort of God mode tools that allow you to do whatever in the games. This is a tradition as old as Doom, as far as I know. But I've heard some horror stories, like if they're used sort of judiciously for all testing, that it could lead to some gaps, because if those tools are assuming kind of ABC happens and then we want to test D, which includes all of those prerequisites, then sometimes you lose the tests which include getting A, B, and C done. And then there's an assumption that it's going to work because, well, it worked when we put it all together. And I'm not saying for obviously your projects, of course, those are a great success. Like I said, my favorite so far. Yeah, it's a fine balance between enabling kind of the overall God mode capabilities and some embedding some automation that can help with testing, but still accounting for those very complex scenarios that lead to the state that you want to get to.
Yeah, Stefan.
Yeah, I think that's a really interesting way of putting it. And I have this thing, I call it the debug uncertainty principle. Right, it's like how much code can you put into your game that helps with debugging and that type of stuff, until it becomes something that is no longer what you're supposed to be testing, right? Because what ends up in the consumer hands is a fully stripped down, what we call a retail build, which has none of that. But if there's too much code, I mean, the classic example, I'll never forget that one, because that was like during the early days, and I think it was on PS1 or on PS2, and I think that took like 2 or 3 days before we figured out what the hell was going on. sprintf allocates memory in some old version of the C++ libraries. So we were happily sprintfing our debug strings and all that stuff. And somehow, memory was getting all messed up and we had no idea what was going on. And those allocations weren't, visible because they were done at the far lowest of all the lowest levels. So it took days to find that out, right? So those are the kind of cautionary tales of, yes, you absolutely need to instrument games for debugging and testing, because you can't do it without it. But you have to be very careful about, people don't go overboard. And because then you get a footprint for memory and CPU and GPU that is no longer representative of the game itself, right? So then you're testing something that's not actually what you intend to ship. And there's been some fairly hefty issues there that where retail builds all of a sudden behave differently because the debug code was causing things to change at the lowest level. So yeah, I mean, that's just something to be aware of, but it makes for some pretty good war stories.
Yeah, for sure. Actually, that's a great segue into this idea of instrumentation and data as part of this conversation of testing. And so, Ryan, actually, on to you, because this is something you thought about very deeply at Stadia, and you have a unique opportunity with Stadia to actually capture and to be able to instrument in a way that might be non-invasive, can be at the system level as well. So I'm curious, kind of, what are some of the interesting things you've thought about with Stadia, and some of the interesting possibilities around instrumentation and observability?
Yeah, thank you. So just want to go off of Stefan's last quote about suddenly there's different things happening underneath the covers that you didn't quite expect. That certainly happened at Stadia, and I think it leads into kind of some of the things that we really wanted to achieve. Because we're obviously like on our cloud infrastructure, we're on VMs, and we're and there are processes that are happening underneath, and there are a lot of conclusions that developers are coming to about the state of the world as they're developing that perhaps could change. And I think that led to, I think a bit of the original kind of complexity of launching games on Stadia is that a lot of the requirements that we had seemed almost like obtuse, or like they're just like so concrete that partners were like, why do we have to do this? Why do we have to do that? And it really went to the level of how complex the infrastructure of Stadia is. And so, from my perspective, we really wanted to give partners that data. And that was part of the kind of original push of, creating an accessible, creating an instrumented stack that partners would be able to automatically get and then glean a lot of information off of. And that was really central to what I think, Stadia's intent is that idea of like, if we can gather all of this information and we can utilize our infrastructure, then, I mean, even back to what Stefan was also saying earlier about, not worrying about the platform and or a platform independent game. I think one of the things that we really want is to create a testing environment that is able to scale with the team. And given that, even in a platform independent situation, there is still a platform underneath. We want to provide that platform. And I think, at the beginning of the pandemic, we were able to help cover some gaps for a lot of teams to be able to keep testing even without the hardware infrastructure that was inside all of their studios, because we had the infrastructure available for them to be able to keep playing their games and keep identifying issues without stopping, especially for the test team. Now, obviously, developers, especially platform developers, need those tools. But for the test teams, we were able to utilize the infrastructure. And really, that's where I think we see a lot of things going. We created, earlier I was talking about how we kind of build certification, and we created this product called Game Runs, where it essentially, at the lowest level, certification is like, do this task and then like see this result, and if you got this result, you did it wrong, and so on. And so when we looked at all of our STRs, especially the ones, like I said, that were more difficult and maybe a little esoteric, we realized that we could actually enhance that experience by just automating all of the generation of those results, right? Originally, when we launched, it was basically like, I have to use the CLI and run this Linuxy command and then do this and do that. And so we were able to essentially allow all of that automation to happen without their needing to do all of those low-level things, because we, theoretically have all that information available to us on our backend, and so we can just understand, what is the results after they do it. And what we were able to lean into is creating kind of two views of the data. One that's live, that's basically graphs and control items and calculators and whatnot, and then one that's historical, which is really a deeper gathering of artifacts, say logs and all that timeline data, like frame rate and memory pressure, and even artifacts of like captures, say like crash dumps and performance captures that can all be kind of associated as one piece of session data. And then that can be shared around the team, making it really, really efficient to kind of start testing and highlighting issues to the rest of your team. Because, as we've said, like the developer, is doing a specific job and have a lot of, has a lot of their own priorities. And so if we can gather all that stuff easily for the tester and or developer, QA, etc., then it makes it much easier for everybody else to just jump in and get that context that they need and hopefully fix the problem easier. And then a separate thing that we're looking at building is on that instrumentation side, where we can, with the game runs infrastructure, and especially with like timeline events, we can allow the game to kind of build their own arbitrary events into the game run, and then have all of that information after the fact to help teams that are trying to figure out why did this crash or why did we drop frame rate. And you can imagine, especially being Google, we really want to grow on that. We want to grow to give even more data and have even more availability. Yeah, so, and going back to the accessibility of content, one of the kind of key features of our platform is that, the content is available securely kind of worldwide. It's how the infrastructure is built. And so we realized that actually also, as a part of game runs, can help with alpha and beta testing. We talked about earlier families playing the games and having it available and getting that feedback. You can imagine that we have a feature called channels now, where you can essentially release your package and release your content to a select set of users. And what we really want to do is build in that the game runs aspects of that, so that you can not only alpha beta test wherever our infrastructure exists, but also have all of that data back. So it creates this kind of semantic of accessibility and instrumentation of data that we think is really, really powerful.
Yeah, so at the infrastructure side, being able to capture that data, and we talked about like collaboration and this idea of like making it accessible. But I'd be remiss if we didn't get tactical for a bit of this conversation and just say what some of the actual data points are. And so Ari, you actually are giving a talk at Breakpoint this year about game crashes, something near and dear to my heart. And so let's talk, one, some more stories about game crashes, but two, also handling crashes within Unreal or even some of the games that you were a part of.
So I don't want to spoil too much about my presentation. But yeah, definitely you need automated crash reporting. If you don't know it's crashing, you don't know if anything's wrong, you don't know what's wrong, and you just don't know how to fix it. So if you check out my presentation, you should, Crashing with Style in Unreal Engine. I do talk about how to get automated crash reporting in Unreal. And I'm very lucky that I realized early on in my game development career the importance of automated crash reporting. So I don't think I missed out on much, but I think I shudder to think about teams that are now making games that aren't even keeping their symbols files, their debug files. And like, if they suddenly figure out, oh wait, we can actually get the crashes somehow from the users, they're just screwed. They can't do anything with them. So yes, keep your simple files. They're just as important as the game itself. Do automatic error reporting or crash reporting on all your platforms, and embrace crashes. Like when a developer gets a crash, they go like, "Oh no!" I always get excited. What's the stack trace?
Yeah, absolutely. Yeah, Shane.
I just wanted to add to that. I think there's a great practice in the sort of enterprise software space that's been quite common for several years now. In like AWS, for example, the introduction of what they call chaos monkeys, and actually causing crashes on purpose, and seeing how your game holds up to not just the positive scenarios, but the negative and even the destructive ones, which is, I think, something that the game industry is probably not yet adopted in a big way, but it's probably going to become more common as these systems become more distributed. We leverage services embedded in the games, like Twitch and others, in the background. The question is, what happens when those aren't working?
Totally. Ryan.
Yeah, and I just wanted to add to that, we, like I said, some of our requirements were a little bit esoteric. One of the requirements was that we wanted all of your symbols that went with the game. So it was a certification requirement. And a lot of teams were like, well, we don't even have this symbol. We don't have, this library is like old and we don't even know where the symbol was. And, it's kind of like platform as a live service. Like we expect that we will be getting crashes in the real world as we are updating our infrastructure. And, it became very clear that it was incredibly important to have those things. And I think, we actually started a relationship with Abel early on because of that specifically.
Yeah. Stefan.
Yeah, I mean, I'm just going to echo everybody's sentiment that a robust and mature crash reporting system across all your platforms and all your games is essential, both during development as well as after development. I mean, the entirety of our QV kind of tech platform at EA has been built on a fully standardized, fully automated crash reporting system, and that's been around for 15 years now at least, and it has become very mature. And is the bedrock of how we deal with our it generates what I call a God level KPI that we call MTBF, mean time before failure, which is used by the entirety of the company, including our C-suite exec, to determine whether or not games are ready for patch or ship, or and we set standards. MTBF on Xbox has to be this many hours, on PlayStation has to be that many hours, and so on. It's a very, very highly scientific data set, and it's regarded as an essential piece of our business.
Yeah, by the way, it's great having everyone talk about game crashes and the importance of them. Obviously, building a company around it, it's just how important it is. But Ari, go ahead. Yeah.
Yeah, and maybe not many. Well, maybe some of them, maybe most of them do. Anyways, I just want to put it out there that it's not enough to just be sending automated crashes for your game. You also need to be sending automated crashes for your build environment, or then I mean like the editor. So for the content creation team, because if they're crashing all the time while trying to create this thing, it's slowing the project down, and you're going to get worse game for it. So that's something we also did at Housemarque. We had the Unreal Editor crash reporter sent it also to the cloud, to a service, and then we could see what is crashing most for users. And most of the time, it was editor code because we made some tools that was breaking the whole thing, but also often the game itself. So then we managed to test it while people were still making it.
Yeah, very, very cool. Absolutely important as well. So beyond game crashes, Stefan, I wanted to ask you some of the other metrics and some of the other data points you look at in that realm at EA.
Mm-hmm. Yeah, I mean, there's a very large set of telemetry that comes out of our runtimes and our backends. Some of it is standardized, so there's a certain baseline of data, and then when, again, crash reporting, our reporting is fully standardized in terms of, here's a baseline of information, like GPU state, CPU state, and so on, memory state. But then on top of that, there is, it depends a little bit on the type of game you're running, right? Like first-person shooter versus sports game have very different requirements in terms of the type of telemetry they need. And some of it is still, generated by our QB teams. And when we're thinking about things like, detailed performance metrics in terms of CPU time and GPU time and so on, to do performance measurement and memory measurement, load times, asset, and so on and so forth. Then there is the layer on top of that, which is game specific, right? So where, like, first-person shooter, it's really important to know where are players going, where are they dying, which weapons are they using, what events are happening, and so on and so forth. So we generate heat maps, and you can see, both for quality verification purposes as well as game design purposes, right? So you see the heat map of a level after, whatever 1,000 hours of play by quality verification and automation. And you see where the bottlenecks are, you see where people are dying too much, so there's something going on there that needs to be fixed, and so on, right? Or where, like, we have our agents that play Battlefield. When they get stuck, right, they can no longer, they're stuck in geometry, they suicide, and they generate a little blip on the map, right? So overnight we run them for a few hundred hours, and then next day you look at the map and say, oh, look, there's all these little red dots where they got stuck. So that goes back to design and they can fix there's some weird geometry that's intersecting wrongly or whatever, right? Which is also very valuable because those are, escape defects that players really don't like and will show up on Twitter and YouTube, minutes after the game's released. So all those things together form this super rich kind of data set, right? And then we also feed it all back into our, we have some of our AI will actually look at those player-generated heat maps or I guess movement data to make their own more natural, so we get better test coverage, right? So it's almost like a self-reinforcing system, which you can only do if you have the right data, which is really fascinating stuff that we really like working on.
Yeah. Continue on. Due to time, I want to look at the future of game testing. And so actually going back to you, Stefan, in one of our conversations, you talked about your team's mandate for the year and really thinking about shifting left and upstreaming quality practices.
Yes. Yeah, so there's, we have this notion of upstream quality. And again, if you start thinking about complexity of our games and the amount of platforms you're dealing with, and even the amount of engines we're dealing with, right? And the notion of, the classic case, well, everything goes into a build, all assets, code, everything, and that build is the thing you test, right? And over the years, we've gotten really good at testing that build, right? Like we have automation and really high quality QA teams and people, However, we're still only testing this build no matter how good you get at it, scaling of that has reached limits, right? We can no longer put more QA people in buildings and even our automation rooms have 4 walls that are now full, right? So what we need to do is start looking at, okay, so how can we test things before they make it into the build, right? So how can we get better at using code analysis tools like static code analysis or even ML-based code analysis to look for defects in code before they make it into the build. Imagine you're an engineer and you're writing code and there's an AI, and this is my kind of the vision that I always tell people so they can understand what it is that we're getting at, right? There's an AI working in the background, looking at your code and starting to underline things, saying, oh, you might want to look at that because, in 80% of the time, this particular pattern has introduced this bug, which was actually fixed by this way because we can look at all our source control and we have all our bugs correlated to check-ins and there's a master AI that looks at all of it. And some of it is already reality. I mean, this is not science fiction. So that's code. And then you can do the same with assets, right? I mean, if you haven't, there's enough the fields of computer vision and has gone to a point now where, we have an AI trained that can recognize the classic rendering glitches, right? Like broken shaders or missing textures or, so you can, in your pipeline before it even makes it to the game, you can render out an object in a little 360 spinny fashion and have an AI look at it, quote unquote, and kick it back to the content creator if there's something wrong with it, right? So those things you can do already, and we are experimenting with those technologies, and we have some of them already going, which makes for that really lowers the kind of the pressure downstream because a lot of these defects get caught before they make it into the build, right? So I think the field of testing before the build is something that is not done yet a lot in the games industry. And I think that's why we certainly need to lean into and really go there because, again, we've reached the limits of our scalability downstream.
Yeah. Yeah, and it touches on a point, Shane, that you made as well, where like with GameDriver, in fact, being useful for the dev, is one mechanism by which you like introduce some of these practices early on, and even prior to, as Stefan said, the build, so to speak. Just for sake of time, Ryan, I wanted to just quickly ask you about how you're thinking about this and kind of shifting left, so to speak, or just generally the future of game testing with Stadia.
Yeah, I mean, I think it's two hands, right? It's where we think the future of gaming is going is to the cloud. We think to Stefan's point, like scaling is really the name of the game, especially in terms of testing. And so Stadia has the interesting kind of problem set of not only we really want to increase efficiency of the partners and the games and the content that is coming onto Stadia, but also we want to increase the efficiency of the platform as it exists, and the ability for the platform to evolve over time in terms of like hardware and software and all of these types of things. And so in both cases, we're looking at trying to use our cloud infrastructure for automation and deeper analysis of the games, not only to help our partners and some of them are not all of the names that are in this meeting now. Some of them are much smaller houses that really can use our infrastructure like they wouldn't be able to any other place. And so that's really an exciting thing that we can activate. And then on our side as well, once you've released a game, you really don't want to have to continue to fix it. And I think we do a great job of not breaking our partners as much as humanly possible. But I think even in that scenario, we want to kind of even more invest in building out automation that allows us to automate our games even more fully that are already released, and then allow those automations to give us signals of our own infrastructure. And I think the kind of going in that and to another point earlier, I do think that the fact that we can create this world in which you can release content to a very specific secure group and then get that data back. We really hope that is kind of that's like we've been talking about QA and kind of pre-release kind of testing, but we really think that that's also a way that we can help developers find the fun. We have like a lot of amazing indies and AAA studios that are making content, and we want to make sure that they're able to instantly and kind of securely share that content with the world and get some feedback as they're building the game, so that they can find that fun. And so those are definitely two of the things that we're really kind of excited about as we move into the future.
Yeah, so with only a couple minutes left, unfortunately, we do have to wrap up the conversation. So many of the topics, though, I'd love to dig in further, and so maybe I can get all of you to agree to another panel where we just focus on some of the elements there. But I'd be remiss if I didn't ask the question to all of you about what excites you the most when you think about game testing today, and what's one area where I would say could use a little bit more attention in the industry. And so starting off with you, Stefan.
What excites me the most is the application of leading edge technologies, machine learning, AI, and being able to actually work with really high caliber engineers and other people in testing to really take it to the next level, which we have been working really hard on at EA. And so far that's been great. It's been a lot of fun, and as a technologist, that's like couldn't be. That's why I get out of bed every morning and do what I do. Things that could use more attention. I think that this topic that I was talking about earlier, this notion of upstream quality, testing before the build, so to speak, left of the build in the process, is something that historically is not fully, I mean, even at EA, it took quite a while for us to really get that concept through to the dev teams and culturally accepted. And so that's something I think needs a lot more attention, because if we don't, like I say, scalability is always looming above our heads.
Yeah. Shane.
Yeah, what excites me most right now is that there's a tremendous focus on quality and testing in this space. You're seeing a lot more talks at places like GDC, which we're going to this year, and a lot more focus in this area. Some great talks online, and just people kind of realizing that there's a significant need to invest in this area. What I think could use a little more attention is in the realm of quality, the instrumentation, the telemetry, the sort of baking it into the process from the very beginning. As Stefan mentioned, a lot of really advanced stuff that's going on at EA, and I think a lot of companies could learn from that. A lot of studios could learn from that experience. Our goal is to try and enable some of the studios that maybe don't have the scale and the budgets that Stefan's team has to achieve the same level of quality that publishers and the studios have enjoyed for many years. But there's hope. It seems like everyone's kind of pointing in the same direction, that this is where they want to go. So that's what gets me out of it.
Yeah. Finally, Ari.
Yeah, I'm going to cheat a little bit, and I'm going to say what excites me more, what I think could potentially come in the future. Because right now, I think there's this great potential for a tool that could help testers automate the boring parts, like smoke testing, for example. Hey, can you please run through the entire game and make sure it still works? We have a new version. Please do it again. We have a new version again today, same day. Can you please do it again? This is just brain damaging. They're like, I've done this 100 times. So finding tools that can help them do that, and that allows the engineering team to implement it with less effort. Because right now, every studio has to make it on their own. They're constantly reinventing the wheel. They have to make an AI or put these spots that they have to do. And I think we could definitely improve that more, and I'm really excited to see how that could be improved in the future. If some company maybe already has a solution like that, they should be raising their hand, or is working on that. yes, helping that. And one thing that I think that could use a little bit more attention, I'm gonna echo a bit what Stefan said about catching things pre-built. And what I'm gonna mention one of my favorite plugins in Unreal Engine, which is the data validation plugin, and that is it's basically allows you to set up rules that validate your data. And if you catch yourself saying to your team, "Hey, remember to always don't save the level unless you," and that kind of stuff, I'm gonna stop you right there. You're making a human problem out of something that is a process problem. So if people could just, when they're saving the level, it just says, "Hey, you made this light static when it should have been dynamic." And make it so easy to add these rules, which we already have. It's in the data validation plugin. You can do it both in C++ and Blueprints. I think people should take way more advantage of that. Catch the bugs before they even make it to the build.
Totally. Go ahead, Shane.
If I could just add one thing, and it's not a sales pitch, I promise. The best place to find defects is, of course, in the requirements. The second place would be in development, and testing is one of the last places you want to find it. But I agree with the previous statements entirely.
Totally. All right. Well, that was a fun conversation. To the panelists, thank you for joining. For everyone viewing, we hope that you got some interesting tidbits. So please, we'll have a Q&A afterwards. Please come ask your questions and the like, or, in the Discord channel, and even contacting and reaching out to us as well. So panelists, again, thank you, especially for everyone across the different time zones. And yeah, hope everyone has a great rest of their day.
Thank you. It was a pleasure.
Yeah, thank you so
Very
much
for having us.
Thank you. Good night.
Cheers. Bye.
Oops, there we go. Sorry about that. Oh my gosh, I'm so horrible on keeping things muted and talking. Well, so that's a wrap up of the 2 streams from the Breakpoint to Virtual Game Developer Summit. So this particular session was the game testing strategies, testability, instrumentation, and the future. This one was very technical, a lot of information on what's going on in the background, and really all the stuff that needs to be done testing wise to be able to ship a game. So it was very interesting, a lot of information to digest and to think about. Both of these sessions we'll talk about on Friday's show, Stadium Connect North. So make sure you join us for that. We'll talk over and see the key takeaways that we got from each of the sessions here with Ryan as well, and his comments and the things that we learned. So with that, I hope everybody has a great rest of the day. Thank you so much for coming out here, joining the stream, watching, and it's great to be able to watch these type of developer focused streams together and be able to talk, chit chat back and forth and comment. It really is interesting. And again, thank you so much, everybody. Take care. Have a great evening, and we will see you all again real soon.
Take it to the next level.